Good morning, guys. Today we are going to go over ways to prove triangles are similar. So we have three methods to prove that triangles are similar. The first one is the angle-angle similarity postulate, side-angle-side similarity postulate, and a side-side-side. So this one only has three ways versus the 5 or 6 ways we have to prove that triangles are congruent. So let's look at each case. Okay, first case. Angle-angle. Okay, if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So as you can see this example, we have a 78-degree angle and a 78-degree angle and a 57-degree angle and a 57-degree angle. So we can see that two of the angles are congruent. Well, we can use angle-angle for this one. And the reason is we know that B and E, these other two angles, would have to be congruent because the third angle has to be congruent if the first two are, because we only have 180 degrees in a triangle. Okay, the second postulate is side angle side. And it says if one angle of a triangle is congruent to the other angle of a triangle. So let's look at that. We got 57 degrees here and 57 degrees here, so we have congruent angles. And the adjacent sides are proportional. So that means the sides on either side of the angle. So if we're looking at these triangles, well, AC has a length of 10. It will correspond to DF, which is a length of 12. And the way you can do that is just look for the two shortest sides and see if they're proportional. So those two are 10 to 12, which is ending up to be 5 to 6. And they have to be proportional. The other two sides also have to be proportional. So let's look at that one. 15 is to 18. Well, if I reduce that by 3, I get 5, 6. So we can see that these two proportions are equal to each other. So both pairs are 5, 6. Therefore, we can say the triangles are similar by side, included angle, and then the side. Okay, and the third one is our side-side-side postulate. Well, side-side-side means all three sides have to be proportional to the corresponding side of the other. So let's look at how we would decide which ones pair up. Well, the smallest side in the first triangle is side AC, which is 10. So look for the smallest side in DF. Well, it's 12. So we would say 10 is to 12. Now, which is the next largest side? Well, the next largest side is 12. And in the larger triangle, the next largest side is 14.4. And then the largest sides are small triangles, 15. And the large triangle is 18. Well, we already know that 10 twelfths is 5, 6. We already know that 15 eighteenths is 5, 6. So just grab your calculator and let's double check for 12 divided by 14. So 12 divided by 14.4 is 8.33, which I believe is 5, 6. Let's just divide 5, 6 and see. Yep. So that one also ends up being 5, 6. So all three sides are proportional with a ratio of 5 to 6. Okay, so let's practice and see if we can figure out which ones are similar. So we have triangle R, that's an R up there, QS. It's similar to, well, R's angle would have to match U's angle. So we would say triangle U. And then T is next. And then S must be 39, just like V is. So UTS, excuse me, by what? Well, what information do we have? We only have angles. Two of the angles match, because if this is 92 and that's 39, that must also be 49. So by angle, these are similar. Okay, I'm just going to double check that just because I want to make sure. Let's see, 49 plus 39 plus 92. Yep, they add to 180, so just want to make sure before I verify that. Okay, so let's look at the next one. We have HGJ, so H to G to J. In that order, we need to name the corresponding triangle that is similar. So H would correlate to, let's see, we've got to go on the short side. H, what I've got to do is kind of figure out which sides go together. So 16 is the small one here, which means 24 is the small one there. So those two correlate. And then 18 is the larger one, and 27 is the larger one. So let's make sure the ratios match. 16 is to 24, as 18 is to 27. Let's just reduce these. This one reduces by 8, so that's going to give me 2/3. This one reduces by 9, and that's going to give me 2/3. So the ratios of the sides are equal, so I need to check that. And then my angle J on either side of this is vertical. So this one's going to be a side, an angle, and then a side. So now let's go back and name them, okay? That means H must correspond to L. So L, K, J is the order. Okay, so that would be L, K, J, and that would be by side. Angle, side, where the angles are equal, right? Because we have vertical angles, but the sides are proportional. And again, you have to show that. So let's look at this one. We have two isosceles triangles. So let's check the proportions. 12 is to 15, as 12 is to 15. Well, that one's easy because they're equal to each other. And they reduce to what? Let's divide those by 3. So that's going to give me 4/5. Okay, that means this base must also be 4/5. So let's check it. 8 is to 10, as 4 is to 5, 4/5. Okay, so those sides are all proportional. So let's name this triangle. So A to B to C could be M to N to P. That's one way we can name it. But because this is isosceles, I can also name it M to P to N. Since those two sides are equal, it could be reflected either way. So now we've seen that all three sides are proportional. So that's the side, side, side similarity ratio postulate. Okay, let's look at this next one. Okay, we can see we have a side here that's 2, side here that's 3, and then we have this length over here that is 3.5, and then we have this side is, this whole side is 6, and this whole side is 4. So let's see, I'm going to draw my triangles separately. It's a little easier to see them if you separate them. You have a side that's 2 and a side that's 3, and then that's angle A. And this is little e. We're doing a small triangle first, and D. So pull that one apart. Now let's draw the larger triangle. Okay, again, this is A, but this side over here is 4, and this side over here is 6. And we do have a hypotenuse, or what looks like a hypotenuse, the longest side. We don't know BC though. So since we don't know BC, we can't compare those sides, and we can't use side, side, side. But what do we know they share? They both have angle A in them. So angle A is congruent to itself, and then let's make sure the sides are proportional. 3 is to 6, as 2 is to 4, and they both reduce to 1/2. So those sides are proportional. So let's see. Triangle ADE is similar to ABC by what pieces of information? Which similarity statement is it? It's side, included angle, side. So side, angle, side, similarity ratio. Okay, let's try this next one. We've got Q, P, R, and Q is given as a right angle, so that one's easy. T must be its corresponding part. T to S to R. Let's see. We've got an angle, and they're both 90 degrees, so they're equal to each other. Now let's take our short sides. 8 is to 10 as 16 is to 20. Let's reduce these. Well, 8 over 10 reduces by 2 to 4/5. And we can divide 16 and 20 by 4, and that gives us 4/5. So the sides are proportional with a 4 to 5 ratio. And then our angles are congruent, so it's side included angle, side. So triangle QPR and TSU would be similar by side angle side. Okay, let's look at ABC. So ABC and X, Z, Y look like they'll be similar. So let's name those X, Z, Y. And let's look. We have a 90-degree angle and they match. Now this angle up here is not given. This one's 40, but we know that if this is 50, this is 40 because these two angles in a right triangle are complementary. So by angle, angle, we have enough information to say the two triangles are similar. Okay, let's flip over to the back like we're at the beach getting a tan. You got GHJ is going to be similar to, we hope, GMK. Sorry, my writing's not real great. I'm doing it with the mouse on my computer. Now, on this one, we are not given much information at all. We are given, though, that we have parallel sides. That's what those arrows mean. So if these arrows are here, that means this side HJ is parallel to MK. So I'm going to draw these separately for a second. Okay, we have angle G up here. We have an angle G here. So guess what? They both contain angle G. And then we have, in the small triangle, here's H and J. And in the large triangle, here's M and K. And we know these two sides are parallel, right? I'm just going to put the little arrows there to help remind us. Well, if they're parallel, don't we know H and M must be congruent because those are corresponding angles? And we have a transversal, and that transversal is GM. Okay, so we can say angle H and angle M are congruent, and that's enough information to say they're similar by the angle-angle similarity statement. Now, some people said, well, you know what? J is congruent to K for the same reason. That's true. J and K are congruent because we still have these parallel lines, right? And we have GK that is a transversal. So again, those are congruent because they're corresponding angles. Okay? So again, if they're overlapping, sometimes you have to draw them separately. So again, we have two overlapping triangles. So let's draw these. So I have A, E, and F. And then I have another triangle, a larger one. And this one's A, B, C. Now, all we're told is these two angles are 50 and 130. Well, what does that tell us? If these two angles are 50 and 130, that means these sides are parallel because those are consecutive interiors. So we can say EF is parallel to BC. I can draw it up here too. Okay, so we have parallel lines. Well, that means we have transversals. So we know angle E has to be equal to angle B because those are corresponding, right? So that means this angle right here and this angle right here are both 50 degrees. Well, that gives me enough information because notice angle A is in both triangles. So you can use angle A and then angle E and B, and you can say these two triangles are similar by the angle-angle. Now let's name them. So E, or A, E, F, A to E to F would be A to B to C. And there are triangles that are similar. Now, if anybody wanted to use angle F and angle C, you can also use those because they're also going to be congruent, because we know that if lines are parallel, these are also corresponding angles. Okay, now we're going to name the statement why they're similar, but then we're going to find the missing part. Okay, let's see what we got. We got JK is parallel to FH. Okay, we also, so that gives us what I call the famous Z, right? If I draw a Z with the top and bottom being parallel, I can get my tucked in angles, which are what? Alternate interior angles. So angle K has to be congruent to angle F. Okay, and also we know angle G is congruent to this other angle G, so JGK and HGF. Those two angles are congruent because they're vertical. We can get these two angles are congruent because of alternate interiors, and we can say they're similar by the very basic angle-angle. That's the easiest one to get. Now let's solve it though. We need to find the length of GK. So we're going to call that X. And now let's set up a proportion. Well, notice this is reflected. So that means angle K goes with F. That means side GK corresponds to FG. So X is to 11 as 8 is to 12. And let's just cross multiply. So 88 is equal to 12x. Divide both sides by 12. And you get x is equal to, let's see, divide by 4, 22/3. And that's what the length would be. So this will be 22/3. Okay, and number 10, let's see if we can figure this one out. Again, we've got overlapping triangles. So let's draw them separately. So this one is S, U, and T, that's the big one. Let's draw the similar triangle, V, U, W. Now notice they both contain what angle? They both contain angle U. So let's mark U congruent to itself. Now we need something else. Well, we've got angle S and angle V marked as congruent. So there's our second piece of information. And so by angle-angle, we can say the two triangles are similar. Now we can find SU. That is this distance right here. We'll call that X. So X is to 26. So this time I'm doing my big triangle on top and my small triangle on bottom. So that's X, and that's 26. And then this is 42. And this is 28. So if we're going to set the second one up, we need to set up 42 is to 28. And let's do, let's reduce first. Because we've got 42 over 28, can't we reduce that to, let's see, 6 over 4, which then reduces to 3/2. There we go. That reduces nicely. Now let's cross multiply. 2 times x is 2x, and 3 times 26 is, what's that, 78. So x must be 39. So there we go. X is 39, which is SU. Now, we've had a few problems in the past where we've had to find this SV. Let's think about what we would do if we know the whole thing is 39 and this portion is 26. Couldn't we just subtract and get 13? So if you ever have to go back and find one of those small pieces, you're just going to subtract those corresponding lengths. Okay, let's look at this next one. We have DCG, this triangle. We have a right angle right here. DGC. And then the larger triangle, which is EFC. And we know we have a right angle here. And this side is 5, and this is 1.2. 5. Okay, and we need to figure out how they're similar. Well, what do we notice? Both of the triangles contain what angle? They both contain angle C down here on the left bottom. They both have angle C. So we've got a right angle, and then we have angle C, so they're similar by angle-angle. I see a recurring theme here. Now we can set up our proportion, because we need to find DE. Well, DE is the very large hypotenuse. So, now that's CE, excuse me. We need to find DE, which is this portion of the hypotenuse. So let's go back and call the entire hypotenuse X. We know that this entire hypotenuse is 3.25. Now, once we solve this, we're going to have CE, excuse me, this entire hypotenuse, but we only want part of it. So let me erase some of this. I've got too many marks on here. What we really need is this segment right here, right? This segment. But in order to find that, I'm going to call the entire thing X, solve for X, and then I'm going to have to go back and subtract to find the length of DE. So let's set up our proportions. 3.25 is to X as 1.25 is to 5. Now let's cross multiply. 1.25x is equal to, grab my calculator, see, 1.25, oh wait a minute, let's clear that, I don't want that, I want 3.25, 3.25 times 5, that's going to give me 16.25, oh, and this should have an x with it, and then we're going to divide by 1.25. So let's see how many times 1.25 goes into 16.25. So 16.25 divided by 1.25, and that gives us 13. So x is 13. Okay, now what did we define x to be? We defined x to be the entire hypotenuse, but we don't want the entire hypotenuse. So let's take 13 minus 3.25, and that's going to give us 9.75. And that's the length of DE. Okay, the last one. Let's set up a proportion here and see if we can't figure this out. Well, just looking at this, do we have enough information to prove that the triangles are similar? Let's see. We could take 44, that's the longest side, is to the longest side in the small triangle, which is what, 27.5? And then 40 is to 25. Okay, let's divide these and see if they are equal. Okay, or you can do a cross product. Let's just use cross products to check it. So 25 times 44. Whoops, that didn't work. Try that again. 25 times 44. Okay, that's 1100. And all I'm doing is just cross multiplying. Okay, and then I'm going to take that 27.5 times 40. 27.5 times 40. And that is also 1100. So I know those proportions are equal. Okay, what is the ratio? Well, let's take the 40 over 25 and divide them by 5. So that's 8 to 5, 8/5 or 5/8, depending on if you're getting larger or smaller. That's the ratio of the sides. So they're equal. We also know that angle P is a vertical angle. So by side, angle, side, I can say the triangles are similar. So there we go. We know they're similar by side, angle, side. Now let's find RQ. Well, we now have the ratio, which is 8 to 5. And so now let's solve for RQ. Well, NM is for my larger triangle, so it's going to go on top of the 8. RQ is from my small triangle, so I'm going to call that X. So 8X is equal to, let's see, 120. So x ends up being, divided by 8, was that 15? So x ends up being 15. And that's how we'd find that other side. So that's how you do similarity, how you decide how to prove two triangles are similar, and then find the corresponding parts. Angles are always similar, right? We know that angles must all be congruent to each other. Excuse me. Angles are congruent, but the sides are proportional. Hope this video is helpful.